Welcome to Metrology lecture series. In the previous lecture, we discussed the Sine Bar and its applications. In the present video, we will discuss the Sine Centre and Sine Table, and also we will be discuss the previous questions on Sine Bar topic for the SSC JE exams. First, we are going to discussing about the Sine Centre. We know that it is very difficult to mount a conical workpiece directly on a normal sine bar. To solve this one, we have to use the Sine Centres. Sine Centres consist of two blocks mounted on top of the sine bar. These blocks hold the centers and they can be clamped at any position along the sine bar. So in the figure you have to observe that one so it is the sine bar, it is the consisting of the two blocks. So these two blocks hold the centers and they can be clamped the workpiece at any position of the sine bar. Moreover, these centers can be adjusted according to the length of the conical workpiece so that the job can be properly held between the centers. Sine centers are very useful for checking conical workpiece because they hold the job firmly, they ensure the proper alignment, they improve the measurement accuracy. The procedure for setting the sine centre is the same as that of the normal sine bar. Angle is set using the slip gauges and the angle is calculated using the sin theta equal to the h by L. Here theta equal to the angle and small h is the height of the slip gauges and capital L is the distance between the roller centers. Next we are going to discussing about the Sine Table. Sine Table is the most convenient and accurate device for the measuring the angle of heavy workpieces. It consists of a self-contained sine bar that is hinged at one end and mounted on a flat reference surface called as the bottom surface. So in the schematic you have to observe that one here it is the consisting of the self-contained self bar and which is the hinged at one end and mounted on a flat surface. This is we are calling as the bottom surface. The Sine Table is very rigid and strong. It provides better and safer support for both the table itself and the heavy workpiece is placed on it. The table can be tilted to any angle ranges is the 0 to 90 degrees by rotating it about the hinged end. When the workpiece is held between the centers, the angle of inclination is measured by the Sine Table. It will be the half of the included angle of the taper. So it is very important. So for the competitive exam point of view. So the angle of inclination measured by the Sine Table will be half of the included angle of the taper. Therefore, using Sine Centres along with a Sine Table is convenient and accurate method for measuring the angle of a taper plug gauge. So next we are going to discussing about the limitations of the sine bar. So first limitation is sine bar is suitable for only small angles. Sine bar works accurately for the angle below the 15 degrees. So this is very important for the competitive exams. And as the angle increases, accuracy it will be decreases. Moreover, it is not practical for the if the workpiece angle is having the above the 45 degrees. Second limitation of the sine bar is the difficult to handle because it is not easy to hold the sine bar and workpiece properly in the position. Third limitation is the small error gives the big angle error. Even a small mistake in height measurement can cause a large error in the calculated angle. So another limitation is the deformation at contact points. So it may be slight bending or deformation may be occur. The rollers touch the surface plate. The rollers rest on the slip gauges. This affects the accuracy. And one more limitation of the sine bar is limited in the workpiece size. So sine bar is comfortably to measure the small and medium size of the parts. Heavy also we can be measured, but not suitable for the very large or very heavy components. So next we are discussing about the sources of error in angular measurement using a sine bar. So first one is the error in distance between the roller centers. If the distance between the two rollers is not accurate, then calculated angle will be the wrong. Second one is the error in slip gauge height. So if the slip gauge combination used to set the height is incorrect, it will be effect on the angle calculation. So next one, source of error is the error in parallelism of gauging surface. The top surface of the sine bar must be perfectly parallel to the line joining the roller centers. If it is the not, measurement errors will be occur. And next source of the error is error in roller size and shape. Both rollers must be exactly in the equal size and rollers must be perfectly cylinder. If there is any difference or shape error causes for the inaccuracy. So next source is the error in parallelism of roller axis. The axis of both rollers must be parallel to each other. If they are not parallel, angular measurement will be incorrect. So next another source is the error in flatness of upper surface. The top surface of the sine bar must be perfectly flat and any unevenness it will be effect on the reading. Next we are going to discussing about the previous questions for the SSC JE exams on the sine bar topic. So first question is the in a sine bar the angle is calculated using option A theta equal to the h by L, sin theta equal to the h by L, tan theta equal to the h by L, cos theta equal to the h by L. So we know that one while measuring the angle with the sine bar, so then relation is the sin theta equal to the h by L. So option B is the correct answer. So next question is a 100 mm sine bar is set using 50 mm slip gauges. The angle is, so here it is given the, so L is given and H also given. So H is the height of the slip gauges, that is the 50 mm, and capital L is the distance between the two roller centers, that is the 100 mm. We know that one sin theta equal to the h by L. Here h equal to the 50 mm of slip gauges, 50 mm h, and L is the 100 mm. So sin theta equal to the 50 by 100, which is equal to the 1 by 2. We know that one. So sin 30 is the 1 by 2, then theta equal to the 30 degrees. So option B is the correct answer. So next question is, sine bar is most accurate for measuring angles. So in the limitations we discuss, so sine bar is suitable if the angle of measurement is below the 15 degrees. So option C is the correct answer. And next question is the, for a 200 mm sine bar, the slip gauge height required to set 45 degrees is option A 100 mm, option B 120 mm, option C 141.4 mm, option D 150 mm. So here it is given the length of the sine bar, capital L is given, and we have to determine the slip gauge height. small h we have to determine, and theta also given, that is the 45 degrees. So we know the relation is the sine theta equal to the h by L. Then h we can be written as L into sine theta. So here L is given and also sine theta also given. Then h will become the 200 into sine 45. So we know sine 45 value is the 0.707. Then h will become the 200 into 0.707. So with then h equal to the 141.4 mm. Then option C is the correct. So next question is the which of the following is a limitation of the sine bar? Option A, suitable for large angles, no error due to the deformation. Option C, small error in height causes large angular error. And option D, used without slip gauges. So here in the previously we discussed limitation of the sine bars, that is the small error in height causes a large angular error. So option C is the correct one. So next question is the distance between the roller centers of a standard sine bar is generally option A 75 mm, option B 100 mm, option C 125 mm, option D 250 mm. So we know that when the length of the sine bar is available 100 and 200 and the 300. So here it is given the 100 mm. So 100 mm is the standard length of the sine bar. So option B is the correct. So next question is the when measuring a taper using the Sine Centres, the measured angle is option A full included angle, option B half of the included angle, option C double the included angle, option D 0. So previously we discussed while discussing the Sine table. So when a taper workpiece is held between the centers, the job is aligned along its axis. So a taper has a included angle 2 theta. Let us consider that is the total angle of the cone. Then theta will become the half angle, that is the angle between the center line and one side of the taper. So here we are measuring the only theta only. Then option will become the B is the correct, half of the included angle. So option B is the correct. So thank you. So this is the regarding the sine bar, and thank you very much.